For this video, we're looking at integrals involving exponential functions. So we know the derivative of e to the u is e to the u times u prime, so it should make sense that going backwards, if you start with the integral of e to the u du, you're just going to have e to the u plus c. So I have different problems of varying difficulty, and they just look different, so I thought it was worth spending some time on. So this first one, you have a very basic problem, and it should be fairly obvious that your u is the 7x up in the numerator. So I'm going to say u equals 7x. That puts my du as 7 dx. Well, in my problem you can see that I have a 3 dx instead of a 7 dx. So I'm going to change this 7 into a 3. I divide both sides by 7 to get rid of it, and then I'm going to multiply both sides by 3 on my du. So 3 dx is equal to 3/7 du. So I have the integral of 3/7 e to the u du. Now I know the 3/7 can come outside, so I'm just going to write it down. And then the integral of e to the u du is e to the u plus c. So this will just be 3/7 e, and then our u is 7x plus c. And that problem is finished. For number 2, it looks slightly more complicated. It actually looks a lot more complicated, but the problem people have generally is picking the u and believing it'll work. So some people try to pick the x cubed because it looks like it has a higher power, but if you have a u as x cubed and your du is 3x squared, then you have no excuse for having this e to the 1 over x squared. So you should try the e to the power first. So I'm going to say u equals 1 over x squared, which I can rewrite as x to the negative 2. So my du would be negative 2x to the negative 3 dx. So if I rewrite that, that's equal to a negative 2 over x cubed dx, and we have found our x cubed dx. X cubed dx, x cubed dx. The only difference between these is that I have a negative 2, and this one has a positive 4. So I can actually multiply both sides of my du equation here by negative 2. So now I have a negative 2 du equals a positive 4 over x cubed dx, and it works out. So this is the integral of a negative 2 e to the u du. And I know I can take the negative 2, I could pull it outside the integral, so I can just write it down. And then the integral of e to the u du is e to the u plus c. So e to the 1 over x squared plus c. And you can always take the derivatives of these to check and make sure you actually get those expressions. So for number 3, a lot of people will say, okay, now you said, use the exponent for your u, but if I choose 4x for my u, my du is 4 dx, and that doesn't explain all of this squaring that's going on. So I'm going to back away from my e a little bit and look at this set of parentheses. So I'm going to say u equals 5 plus e to the 4x. So my du will equal the derivative of this. The derivative of 5 is 0, and the derivative of e to the 4x is 4e to the 4x dx. So if I rewrite this integral, I have the integral of a u squared, and it still has a 7e to the 4x dx. I need to take my du and turn it into 7e to the 4x dx, and it's not that hard because they both already have the e to the 4x dx in them. I just need to change this 4 into a 7. So I need to get rid of the 4. I'm going to divide by 4. That cancels out, and I need a 7 in there. So my 7e to the 4x dx is actually equal to 7/4 du. So I rewrite it. This is the integral, and I'm going to put the number up front. It's 7/4 u squared du, and we're ready to just use the power rule. So I'm going to add 1 to the power. Now keep in mind this 7/4 just gets brought down, so I've added 1 to the power. Divide by the new power. It's multiplying by the reciprocal plus c. So multiply straight across. This is 7/12. My u is being cubed, so my u of 5 plus e to the 4x gets cubed plus c, and that's the answer. And you would use u substitution to actually get it back to the original if you want to check to take your derivative. Number 4 looks a little bit more complicated. It's a real question. If you pick this as your u, then your du would have a 3 in it, but it wouldn't actually have an e to the x in it, so we're not going to do it that way. The special thing about this problem is that there's one term in the denominator, and there's one term, very often you can split it up, so I'm going to try that. So I have e to the 3x over e to the x minus a 2 over e to the x, and this is what I'm actually integrating. These are equivalent. So if I look, I'm dividing two things with the same base. They both have an exponent. I know I can subtract my exponents. So e to the 3x over e to the x, when I subtract these, 3x minus x is 2x minus a 2, and then this is an e to the x that's in the denominator, so I'm going to bring it up with the negative exponent, and I'm integrating this. It's helpful for people when they first start these problems to actually just integrate term by term and write it out term by term. So this is the integral of e to the 2x dx minus, and you can actually pull the 2 out, but I'm going to leave it in there, minus the integral of 2e to the negative x dx. They're two separate problems with two separate u's. So for this problem, u equals 2x, so du equals 2 dx. And you can see that there's no 2 there, so it's a very simple process. Divide by 2. And my dx will equal 1/2 du. So this is a 1/2, the integral of 1/2 e to the u du for this problem. For this problem over here, my u equals a negative x. So my du equals a negative dx. And I could turn this negative dx into a positive 2 by multiplying both sides by a negative 2. So this cancels out, and I have a 2 dx, so I would write this as the integral of a negative 2 e to the u du. So what I'm going to do now is just write my almost final answer, I suppose. So I have my 1/2 e to the u, the 1/2 comes out. The integral of e to the u du is just e to the u, so e, and this u is a 2x, minus, and then you'll see I have a negative 2, so I'm going to change it to a plus 2. It's an e to the u again, so the u for this problem is a negative x plus c. Now there's nothing wrong with this, but you'll often see it written in a different way, actually lots of different ways depending on what you're doing. But this is an e to the 2x over 2, and either one of these is fine, plus, and now I'm going to bring this down to the bottom, so 2 over, it's e to the negative x, e to the x in the denominator, plus c. And that is the integral of number 4.